So, first panel. It's a panel on peer-to-peer layers, intent gossip networks, and the edge of distributed systems.
Test, test.
Test.
Yes. Test the mics quickly.
1, 2, 1, 2.
Oh, no.
1, 2, 1, 2. I think it's working. You want all of them listed?
Hello.
Okay, Tobias.
Yes.
Take it away.
Is it working? Yeah. Go, go, go.
Thanks so much, everybody, for coming. Can you hear me? It's hard to tell if it's actually on. So today we are going to be talking about the P2P layer. And apologies in advance, because I just got off of a plane from New York. So this is going to be a fun one. So we have an illustrious panel today to talk about what is maybe the most underlooked part of the blockchain. If a peer-to-peer layer works correctly, it's kind of an invisible structure. So I think it doesn't get the attention that it maybe deserves sometimes. I'd like to just start with, if you could introduce yourself, name, organization, just a little bit about your work and how it touches the P2P layer, just a sentence or two. So Tobias, maybe we can start with you.
Hi. First off, good morning, everybody. So first panel, we're on. I'm Tobias from Anoma. No, from Helix. And Helix is the people behind Anoma. And what I've been doing all day long, a lot of research, actually. So very theoretical stuff, but in particular distributed systems. So you've heard about that. Ava gave a great introduction of how all the pieces are moving inside our company. And I'm definitely on the research side. And now back to the question, actually, of Sam. So how does this relate to the peer-to-peer layer? So we're doing complicated things, consensus algorithms, which are deep down in academia. And now we are hitting the real world in that certain assumptions we're making there might or might not be true, actually. And this is really, in short, now the one sentence. We are relying on the peer-to-peer to bring messages from A to B. And as simple as that sounds, it's going to be a long journey.
Marius.
Yeah, hi everyone. I'm Marius Poke from Informal Systems. I'm working in the hub team. So I'm more on the application side as an end user. So we are focusing a lot on interchain security and yeah, making the hub the greatest place to launch a chain and everything. So on the question of the peer-to-peer layers and how we are experiencing this is more on the end users and how this affects an actual chain, right? That is in production. We are using Comet BFT. That is a well-known protocol. It's tested in production. So yeah, we had our past experiences with the mempool and the peer-to-peer layers. So yeah, we're very excited to be here.
Yeah, a lot of trials and tribulations there.
Hello, everyone. I'm Wondertan. I'm from Celestia Labs. And I'm bringing here more sort of like an engineering practical angle to this discussion. I'm doing more of an engineering rather than research, although I enjoy doing research and looking for new algorithms and consensuses and how it all mostly related to the P2P networks. In Celestia, we have 2 P2P networks, so we have 2 troubles to work with. And first one is the common BFT one that we try to scale as much as possible with higher throughput for bigger blocks. And the other one is the DA network, where we mostly focus on the light lines and ability to verify and sample the data that is produced by this consensus network.
Great. So like I was saying, if the P2P layer is working correctly, you kind of don't see it or don't notice it, at least as a user. And I think this is a timely discussion because there's a couple of things that are kind of pushing against that where we are starting to have to look into it more. One is intense. I mean, you're kind of relying on the latent capabilities of the network much more than you would otherwise in a typical blockchain. And the other is just the kind of increasing complexity in something like the Ethereum supply chain, where you're actually pushing a lot of work outside the P2P layer, communicating directly with validators, and this kind of harms the potential censorship resistance of the network. You end up with something that looks much different. So just wanted to start the conversation with a quick kind of survey of what we actually think a good peer-to-peer layer looks like. What does it do? What capabilities does it provide? What is the kind of foundation that you're building on? Maybe we can start with you, Wondertan.
Sure. So the question is, what makes a good P2P layer, right? And my take on that is it should be pretty minimal. It shouldn't try solve all the problems for you. And in the end, it should be just a set of certain primitives that you can take and develop on top your more application-specific or more like protocol-specific protocol that you can use for things like intense gossiping, maybe blog gossiping, maybe transaction gossiping, whatnot. So this should be like just a set of toolings that tries to make as minimal assumptions as possible on how the layer above works, so that you can take these pieces and you can like ideally even modularize them to the point where you can, if you realize that there's some bottleneck in there, you can just remove one piece and put another one. The ideal P2P network should create as less problems for you while solving some concrete set of problems. It should take care of things like connection management. It should take care of things like resource management. It should make sure that like some like simple things like, oh, there's so many connections coming from one particular IP, and that's clearly a bot. Like even cases like that, you should be able to see that, okay, this IP is collocated, so we don't want to accept too many connections from that. Even from these low-level stuff, it should be able to take care of that. It should also provide you some primitives to like gossip information to a certain degree. And like gossiping in itself is a hard problem that you like cannot make a one algorithm that will solve all the problems. But you can still like have at least some like first steps on simple primitives gossiping algorithm that you can iterate over and like start building your application, and then later on you can just go in there and remove pieces of that and like optimize for your use case. Another thing, like a nice thing to have in like within the P2P stack is ability to discover peers, like peer discovery or maybe like peer exchange. You want to have these primitives in your P2P network so that you can discover more nodes that are serving some particular service for your needs. This is what also like nice approach of Anoma's P2P design, where they make these heterogeneous DHT network where you have like multiple domains, and all these domains are allowing you to like sort of have an affinity of certain peers that are interested in some application that you can like stick to, and all these subdomains can like help each other depending on the like if there's like some sort of attack happening on the one domain, you can like other domains can help and heal the other DHT. There are actually many things, but I don't want to like.
No, that was a great start.
to take all the time. So,
anything to add?
Yeah, in my view, I think if you are thinking of the main concern that is addressed by peer-to-peer layer is dissemination of information, right? At the this is the basic concept, right? And what's important, it needs to be efficient, clearly, and but also shielded. The users should be shielded from it, right? The normal users of whatever your system does, right, shouldn't need to understand what's happening below, right? So that's the reason it's good to be efficient and very important. So I think this is a requirement. It needs to be to protect against spam and attacks, right? So to be able to degrade the performance of the peer-to-peer system to degrade slowly in case of an attack. So yeah, for that it's necessary to also separate this concern from the rest of, like in the context of blockchains, for the rest of the system, right? From ordering and consensus, from execution, all of this, right? So in this way, we can optimize it to do exactly what we want. Yeah.
Yeah, so that brings up kind of an interesting property of the peer-to-peer network, that it's almost more challenging to work with in a way because you don't have the full information of consensus. And you often have to deal with not only validators, but a wide set of actors who may just be kind of joining the network ad hoc. So you mentioned kind of peering with different parties in the network. What kind of facilities do you think you need to kind of handle that, the address book, or kind of identifying and managing reputable peers?
So I'm clearly not an expert in this, but I don't know, we were talking before, it feels to me that this is already something that was heavily researched in the industry, right? Because even before blockchains, we have peer-to-peer networks on different layers, right? We have them in BitTorrent and stuff like this. So you don't need to actually need total order to need a peer-to-peer network. You don't need blockchains. There are different mechanisms to improve the connectivity and to address this. So a reputation system can be useful. A system based on we need a metric of what does it mean to have good connectivity, right? Why would you connect to those peers and not others? How do you change your peers? And so on. And that depends a lot on the user needs. Why are you actually doing this? What type of dissemination do you are doing, right? Do you are disseminating transactions? Do you disseminate intents? Are you disseminating blocks? What exactly is the target that you are trying to optimize for? So I think an example could be a DHT. So you just use different, like, if I'm getting good data from that peer, I will keep it. If I stop getting good data from that peer, I need to change it. Of course, this is very minimalistic.
Great. What makes a bad peer-to-peer system? We kind of mentioned before, Tendermint, who most of us have worked with, has a number of warts. There are a number of issues of kind of mixed abstraction paradigms, just challenges with network degradation, particularly under load. What are some of the kind of things in the wild that you've seen that have kind of troubled you?
Flooding.
Say more about that.
Like the worst thing you can do, but it also works as a first step. You can just take all the peers you have and just send all the messages to them. This would be like a simplest thing to do, and but it also has a detrimental effects on your network, of course.
The interesting part is that actually theory department says this is the thing to do. So yeah, there's certain tension. Yeah. So I have no experience from what is happening in like real peer-to-peer networks, as I'm mainly trying to be a user of them. So for example, flooding, what is the problem with flooding is that the thing just doesn't work anymore, right? It's just like, it's just a specific, it could be like a denial of service attack, right? So you just spam all and every node in the system, and then you have no communication that is meaningful, at least. So, and exactly so, that is, of course, then the question: how do we deal with that? And yeah, that is actually like one of the hardest problems, I think, out here to make sure that the thing just works.
So from experience from the last year, right, we had some incidents of flooding with the Cosmos Hub. And it's very interesting to see this because it's a trade-off, right? It's nice to have flooding because you have faster dissemination of the data, faster transaction inclusion in the blocks. But at the same time, indeed, what you're saying, if you have too much of that, you are killing the entire peer-to-peer layer. So what we noticed in those attacks, actually, the main problem was configuration, right? Because it's a local problem. Every node can configure what they are disseminating, right? Their peers, what type of data. Now, what we notice, if you have inconsistencies in this configuration and what you accept as a valid transaction, so you have inconsistency in this validity property, then you create this subgraph that starts disseminating a lot of, so they are filling in that mempool with a lot of nonsense. They are disseminating that, and basically they are killing their throughput completely. And the rest of the network will progress, right? And that was actually the case with the hub. The hub was never down during these attacks, but some nodes experienced problems. So this is an interesting thing to see how you can simplify the configuration. How can you simplify the system so that everybody can configure it in a way that it works as a whole?
Yeah, just a side note, one of the kind of interesting solutions or partial solutions was the introduction of randomness into the flooding mechanism. So just randomizing when you are flooding the network, you are actually disseminating transactions, and that reduced the amount of amplification in the Tendermint P2P transaction dissemination scheme. Anything to add on what not to do in when designing a P2P layer? You've been thinking about new directions for P2P. What are you trying to avoid, Tobias?
So I'm, again, sorry here, really sorry. I cannot tell you exactly where we're going with a peer-to-peer layer. Not because it's top secret, but it's really like active research, which mainly my colleagues are doing. So what I can tell you is that we are aiming for this heterogeneity of several domains, which already Flip was kindly referring to. So one thing we try to do is exactly build, like, essentially a counterpart maybe to zones and Cosmos that you have, and very specific protocols that are spoken by a specific domain, as it's called, of nodes. And then when we can have these specific domains operating and have specific guarantees that we try to prove actually to hold for if sufficiently many participants actually do what they should do, so to speak, then we can hope that these together form a stronger network, and also just, and now right now brainstorming here and doing research on the stage. So if there's a flooding attack in one of the domains, then the other domains can say, well, careful, these guys are in trouble. So what do? We kind of like just cut them out because they sort this out, better sort this out. We don't have the means to help them. Or is it still like, can we still recover it and kind of help them by putting resources in terms of bandwidth, or I don't know what you have to help them get back up to speed. So I think the cue that I was actually having in my head for a long time is exactly what Wondertan said. You have to have a very clear vision of what the peer-to-peer network is for. And that actually goes back to a question of Sam in the beginning. So what is a good peer-to-peer network? And the straight answer is the question doesn't make sense. You have to be exactly sure what the thing is for.
Love that.
Sorry. Yeah, somebody has to keep the show running. Well, I don't want to degrade myself into the clown, but the delicate question is actually like, yeah, what is the peer-to-peer network for? And just to put it back to me, when I was starting to interact with peer-to-peer researchers, and that's the last sentence here in my speech, there was always a question like, Tobias, peer-to-peer network, for what? For exactly, be it intense dissemination, be it like, we're not streaming on Netflix, right? There's peer-to-peer networks just for streaming. There's a whole body of literature. That's a long sentence. Yeah, so in short, we want to be specific about what the peer-to-peer layer is for, and we want to specify it before it's implemented.
We were talking at the table previously, and you had a great turn of phrase, which is the peer-to-peer network is by the people for the people. Contrasting this with a lot of like distributed systems literature and consensus literature, I got a kick out of that. So that's what it's for, the people.
Do you mind if I add here?
Oh yeah, absolutely.
So there's like one learning that I had over not a huge experience, but like which also adds on top of what Tobias was saying about what makes a good P2P system. It's sort of a wrong question because you cannot make sort of like a one P2P system for everything. And there's a good example of such a system that tries to make it to be that. And like I've tinkered a lot with IPFS, and I want to mention this because they are very P2P focused system. But one of the problems they were having is that they try to overgeneralize everything to make like a one thing that solves everything. And they, I wouldn't say we're able to achieve that goal. There's still a lot of inefficiencies here and there if you won't just go and use a generalized approach. And all the time you need to go and make your specific P2P system for you optimized for your needs. So there can be just one good P2P system.
Mm-hmm. So, I mean, what we keep coming back to is kind of like a network of networks type design. I mean, that's what Anoma is, but also something that you've been interested in. I wonder how that kind of plays out in the Celestia context. What is the network of networks in that P2P design?
So the current Celestia's design does not like involve a one shared P2P network in this like up for other applications. For now, it's mostly like a P2P network that does one thing. It just does the data dissemination. It's sort of like content delivery network in some way, which does sampling additionally. So you send the data and you get the data and you ensure the data is there and you like do some additional proof verification of that data. And it's for now it's only optimized for that purpose. In future, we may consider using like sort of a domain approach and make like a shared P2P layer for all the applications that are building on top. So we have like a concept of a namespace, which is like an identifier for the application. And in future, we will develop a thing called like namespace nodes. So you will be able to run to your namespace node, which is connects to other nodes in a namespace, and it may be like actually provide this base layer infrastructure for the applications, and that will move us towards to this one P2P layer for other P2P like applications. But it's still like something that needs more exploration.
Mm-hmm. Can I also, so very similar to this is also, so currently the commit team at Informal is working on, so instead of having multiple networks, is splitting the same network and creating mempool lanes, right? So then it's similar to the SDK, block SDK lanes, but it's done at the peer-to-peer level or directly in Comet, right? The advantage of that is that you can separate concerns and try to optimize for whatever user needs. So basically, each lane will fit differently into the peer-to-peer layer, right? So, and that comes also at what cost of resources, right? And this is a very interesting thing because then you can start optimizing and providing or guaranteeing different quality of services depending on the use case, on the application. At the moment, at least in Comet, everything goes through the same pipe, right? And even worse, nobody pays for it, but we skip that part. But everything goes through the same pipe, and then you cannot really optimize, right? Because if you have a use case where, for example, Celestia needs a lot of throughput, right? Cosmos Hub doesn't really need throughput at the moment, right? So you don't really need to optimize for throughput. But there may be applications that you want to optimize for latency. So it should be probably a different lane or a different dissemination strategy.
Yeah, in both the Anoma and Celestia, and I guess the Cosmos Hub with its kind of network of networks design, do you imagine kind of tailored mempool, tailored P2P for that application domain?
Can you read the question? Sorry, I'm also not quite awake.
So we've gotten to this place where I guess we all agree that there's no one-size-fits-all P2P, and we all have network of networks going on here. So what's kind of happening at that tailored level of the single network? Are those going to be you can adjust them in some way and optimize for throughput or latency or different characteristics?
So I go. Clearly, we're going to have validators, and I announced already there's going to be like the all-encompassing Anoma answer. The short answer is like there's some nodes which are primarily validators, and they will have like a specifically tailored P2P network, and that it's supposed to be extremely reliable and robust, because if the consensus goes down, which is what the validator is running, the chain is at a halt, which none of the users want either. So now for the full disclosure, we're going to have this role of participating in peer-to-peer for each node, probably in Anoma. So you're going to run on your hardware one piece of software, which, among other things, is doing peer-to-peer participation in one or several domains. And this is what we have. And then, depending on which specific role you are primarily interested in the Anoma ecosystem, it must not necessarily be the validator. It could be the people that try to match intents or solve them, or do counterparty discovery. Then again, like you would have, essentially, like again, you would be part of a peer-to-peer network, but you would be, in a sense, like possibly in a different domain, as you're having different goals and different quality of service requirements. And there we are right now focusing, last sentence, of course, first and foremost in Typhon about like what we're going to do in the peer-to-peer network for the validators, for consensus and log mempool. And in the long run, of course, we also need to think about how we do intent gossip.
Cool. Yeah, so I want to talk a little bit about the incentive. Marius, you touched on this a little bit, but like, because you don't have consensus, you have less to work with, but there's still a pretty wide range of incentive design that you need to take care of, and particularly like this is kind of where the censorship resistance of the network comes from, is P2P. So wondering if you all could kind of talk about what tools do you have at your disposal, what are the kind of incentive challenges that you kind of think about most, and how are you going about solving those? Anybody?
Yeah, I can take this one. So as I was saying before, I was kind of alluding that nobody's paying for gossip. So it's kind of people pay through transactions, right? So submit a transaction to any chain in Cosmos, you are paying a fee. But the fee comes from the gas consumption, right? From the SDK. So it's at the application layer that is calculated and is for storage, for execution, basically. However, you don't really take into account the dissemination of data, the gossip, which is very expensive. The storage at the commit level, right? So this is, you may pay for block space, but you don't really pay for the peer-to-peer layer. And this is something very interesting to kind of correlate the gas usage or the cost of the transaction with the amount of resources that you are using. And we were talking before about, it's not trivial to do that, right? Because it's kind of, so yeah, Chris was mentioning that in a centralized way, you can do this immediately, right? It's graph theory. You can just, so you know how to do it properly. Tobias.
Come and say it. Come on, say it.
So yeah, it's in a centralized way, maybe a problem that's already solved. However, to do it decentralized, you need to somehow agree on what's the state of your graph, and that you need to reach consensus on that. So based on that state, you can kind of figure out some metrics of resource consumption, and then use that to decide what's the incentive, right? What's the incentive for nodes to disseminate this data?
Yeah, so there's kind of like a chicken and egg. You don't have consensus, but you need consensus to do any of this. So
now comes the point where it's getting interesting. So I totally agree, and we all would like to also work all the mechanism design. So I also did a tiny bit of reading up on peer-to-peer general literature. And the big, so to speak, claim now here is that actually this is maybe, it should be now, yeah, this is the claim, it should be just a public good. So this is now speaking for myself. It should be a public good.
What should be a public good exactly?
The peer-to-peer layer.
Just the entire peer-to-peer layer.
Okay. Just to get the conversation going here. So Marius said, who's going to pay for this, right? And it's a little bit, not going too far off this tangent, like public services, like maybe public health services, right? Everybody's paying for this, and everybody gets it who needs it, right? Objections?
Many.
I think we're all on board with that.
Okay, cool. Here's the conversation, fantastic. So back to the topic, peer-to-peer networks. So yeah, in the ideal world, this would be a service that everybody is getting offered by the community if used wisely. And yeah, and then the question is, of course, how do you make this line? And it's got to be bloody difficult. But the main reason, actually, for selfish reasons, coming back to who's going to pay for this, so it might be a centralizing force in that if you want to have a decentralized peer-to-peer network and you start to give out incentives for participation and good quality of service, you might end up centralizing. So this is the other point for actually this thought in the back of your mind that it should be public good, should remain there as an ideal that you might want to head for if possible.
So do you say it's P2P layer should be sort of altruistic in some way? So the peers that are joining the network, they should be doing good job for the network for free. Is this your point?
So I now disclose that I've grown up in Germany, and there's the Chaos Computer Club. And I don't know these people really, but they have this, and I'm quoting this probably wrong, idea that everybody should have access to computers and network. And this was primarily, of course, access to the good old last millennium Web 2.0, right? This is what they're talking about. But if you think things through, you will end up, well, okay, things have changed. We're not using, I don't know, Mosaic anymore, if anybody knows what that is. And we are now in intense land, right? We want to get our intents from us to the solvers, to the validators, so that they're settled. And yeah, if you think this through, taking the same spirit of the Chaos Computer Club is everybody should have access to our dear blockchains, all of them. And that's only via peer-to-peer because you cannot ring the bell. You have to send it over the wire.
So I'm going to play a bit more of a devil's advocate here.
Fantastic.
So
Awesome. Cool.
Okay, we have these public access to everyone to join the network, right? But these nodes, there's still little hubs there that perform some active work for the network. How are these nodes should be take some sort of revenue to pay for the infrastructure they're paying for all the bandwidth they're giving out to the network. How should they get the stream revenue from that and like pay for that?
So here comes two things. First thing, a simple example how this could go. And there's a project that's called Freifunk. It mainly exists in Berlin, where I'm based. And you just get free Wi-Fi. There you are. And you just have to find an access point in your neighborhood. You just have to maybe move. Or you just put the thing up yourself. And interestingly, I'm told from my dear colleagues, which are much more down closer to the wire, that if you tell them, yeah, look, I give you money, why don't you make a, and they would just, no, you don't take money, we do this is our thing. They don't want money, it just spoils their fun. So interestingly, these people are not quite into blockchain land. They don't like us so much, I'm told. I have to verify this. So Freifunk, awesome project, they just give you internet for free. And we just need the same thing for P2P somehow. I don't know how, right? It's like this thing like, well, we are here, we should go there, and blah, 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 we do something. But just keep it in mind that this would be the ideal solution. And I don't know, is somebody in the audience that knows how these TLS certificates are chucked out all the time and at increasing rate, and it's also a free service. So basically, if I remember correctly from a real-world crypto conference, it's that these people make your connection to the internet safe every day, every second, every millisecond.
So I think some people maybe think that's far-fetched. Some people might agree. The whole notion of an Ethereum home validator is this, basically. It's just kind of donation to the network. I mean, you rarely mine a block with an Ethereum home validator. But in this peer-to-peer setting, I think it's not Freifunk. It's worse. You know, there's actually people who are trying to abuse the network, and it's not just a tragedy of the commons. It's actually like there's malign actors who are trying to disrupt the network. So that feels very challenging to just rely on altruism. What do you think the approach is there? It seems like you have to have additional mechanisms to make the network legible, to kind of understand health, and to make sure that actors that are interacting with the network in that way don't remain peered.
Can I? Like that's a big question in general. Like, how do you make sure that the peers you're talking to are not like Sybils, they're not bots, they're not like any sort of malicious actor. So, and one thing I know so far is that there's no like way to make one single big reputation system for all the peers, and like one that will be objective for everything. So I see this problem as more like every single peer should have a subjective way of tracking the peers it peers to. It's sort of like if you think about peers as like human beings and how do we connect to each other. Everyone has some sort of way of understanding which people we trust or we don't trust. And we also have some scoring system for people we talk to, and we like have a trust levels that are different for each person. And you can, I think, kind of codify it in the peer-to-peer software. You can make systems that's like that tracks how long have you been with that peer, how long have you been in connection with that peer, how many valid messages have you received from that peer, how many good things you also gave to that peer and back, how many invalid messages you get to the peer. And you can also apply some specific application, specific scoring to this scoring system, and you can add more like heuristics to the scoring thing. And you can even make an AI, I think, out of that. It will like be smart enough to like analyze your peers. Maybe it's a bit too far from now, but I feel like that might be a direction we will go to. So yeah, that's my take.
Cool. And I mean, this is how most peer-to-peer networks, even non-crypto peer-to-peer networks, torrents, and I know Scuttlebutt has a similar concept. There's also oftentimes this kind of like hub or node that's like just it is more altruistic, and it's like actively gossiping in a way that is seeking out information and actively gossiping rather than just kind of passively absorbing information. And so maybe there's ways to kind of like bootstrap trust off of a node like that.
But a good analogy, I think, it's consensus systems, right? So solving consensus. If you remove malicious actors, consensus is very simple to solve. It's ridiculously simple. Once you add malicious actors, it's crazy complicated, right? You have so many edge cases, so many things that can happen. Somebody thinks of a crazy way to attack the system, and we need to have these complex systems that are slow usually, very slow, right? So the same thing is with the peer-to-peer network, right, the layer. If you remove the malicious actors, you can create a simple, okay, I'm telling you, you tell the next guy, and we go on. But if not, you need to have redundancy. And you need to have redundancy, and you need to be resistant to spam, and all of these things that are costly. But I don't see how, so I resonate with the idea that you are suggesting, right? I would love that for this altruistic world to exist, but there will be always somebody that is trying to mess this world, to try to destroy this ideal system. And that's the difficult part.
Okay, maybe a little bit more for a concrete solution and an alternative called out here, obviously. Basically, there's in my head at least, the good old validator group is run by people that make some profits typically, and in a sense, I mean, slightly going off the totally ideal world where it's sponsored completely. It wouldn't if it was like taxes, in a sense like the big validators pay taxes, and then from these taxes we pay essentially the peer-to-peer network. And this might go in several steps, in that first and foremost it should be that each validator does their own peer-to-peer duties. And this works, again, like at the level of consensus, I know how this works. But as we are also talking about intense gossip, there my level of expertise is degrading fast. And Patrick is looking at me as if I'm saying something wrong. I hope it was not too far off, but roughly like it's, yeah, so the validators should have to run peer-to-peer nodes, and they should prove that they provide their service. And if not, they should maybe even be slashed in case they don't do their job. In a similar level, I could imagine that. I mean, I find it scary, all this supervising other people, but that they do the right thing. This is borderline edgy, and you might think of it like, well, it's just peer-to-peer nodes, but in the end, it's the users also that might participate in the peer-to-peer node to gossip stuff around. And there, in a sense, we should also try we have to think about well, we cannot say that word. We have to think about to not divulge information of the user that user doesn't want to divulge, and also known as privacy. So, and there it's getting interesting, and like, how do you even like maybe like I think in that, if you go that far out, I think there's some kind of thing where there's enthusiasts that run the local, I don't know, hub where you send your intents, and you get a suitable level of privacy. And that should be also cheap. It should be run on your phone, essentially. This is actually like a terrain where I could think terrain. I think not a terrain. That's something else. A terrain where this could work. Actually, the ideal world. And then if it's going closer to the validator, it should be the validator doing it. And then there's this whole middle ground that I have no idea about. And if I have raised the if somebody thinks I know this in between, and no, I don't. It's really research. We have to do this. Okay,
I want to change tacks a little bit. I mentioned this in the beginning, but when you look at the Ethereum supply chain, what is the peer-to-peer layer for at this point? Like, builders take in the transactions from private order flow. You have PBS, private proposer builder separation. So they deliver the entire block, and then basically the peer-to-peer layer is just like disseminating the block once it's already been delivered. And I mean, I think part of this is due to just PBS not being ideal here, but there's always kind of this like pressure to circumvent the peer-to-peer layer, and so how do we kind of push against that inclination to avoid using P2P because it's less efficient or not as profitable, or
efficient protocols, I think, right? So centralized solutions are always cheaper, right? There is a trust level. Apparently, users don't really care about trust. So they're okay with just going on a website and pressing a button, and many users are okay with using their bank, and they trust their government and all of this stuff. So that's the majority of the world. We are at a blockchain conference, right? So clearly we think differently. For us, trust is important, so to have trustless systems. The peer-to-peer network, or these peer-to-peer layers, enable decentralization, right? They are very difficult to build. So to have some sort of, we were talking before, Tobias, about intent gossip, right? And I was asking a question like, why? Why do you need this? Why don't you just have a front end that is taking your intents and then just submitting transactions to the systems, right? That's a centralized solution. It's simple to be, it's much simpler to build. I'm not saying that it's trivial, but it's simpler to build. Creating some sort of decentralized peer-to-peer layer that will take intents and distribute them across the entire solver cloud or whatever it's called, like all the solvers there. And then going further, it adds latency, it adds complexity to the system. And that comes at a cost. So yeah, more efficient protocols, I think.
that sounds like the end of the peer-to-peer layer to me.
You can say that centralized way of like disseminating the data, it's also like a type of P2P communication. You have this node that is like doing the PBS, building the block, and you have all these clients that are preferring use the off-chain agreement way to just like flow all this transaction to that centralized builder instead of using the P2P layer. But it's like, it's also sort of like a P2P, you can say that, but also I think it's a problem of like incentives. Like there's more incentives for you to do the private order flow, and there's too much power that these builders have right now in the Ethereum world, and it's a huge centralization vector that is just more efficient to also disseminate data. So it's kind of clear why is this happening. The question is how to fix this, and the only answer I have is like just fix the incentives, but it's also like a very vague answer.
Just one more thing, I was just thinking now that regarding the users, right, and this idea that they don't really care about trust, I think what we can do as a community, the blockchain community, is to change the story. Instead of saying, use these systems because they provide trust, you don't need to trust a central exchange or a central bank or something like this. I don't think there is that much. There is a niche, of course. There are people that really they don't trust their bank, but most people don't have this problem. What they care about is access. They want to have access. So an interesting example is Cycles, right? So it's the solution built by Informal for getting access to credits, right? This is something that you don't get in the real world. It's not that you don't trust it. Normal people cannot get that. DeFi was the same, right? You cannot get access to, you cannot get a loan. You go to the bank as a normal person. It's not that you don't trust your bank. They just don't give you the loan. You go on a DeFi application and you can get a loan of 100 ETH, right? And this is pretty cool as a normal user. So I think the the story should not be about how do we enable trust, and that for that we need a decentralized system, is how do we enable a censorship-resistant system, and for that you need decentralization.
Yeah. I would say privacy is one of the other things that you don't necessarily have access to in centralized models, so that could be pushing things into the peer-to-peer layer. So we only have a minute left. This was a very interesting conversation. I just want to close talking about intents. We actually didn't talk that much about it. Marius, you had an interesting comment about intents just kind of being an additional kind of shell of peer-to-peer gossip. Tobias, I wonder if you could just kind of say a word about how you're thinking about the peer-to-peer layer with respect to intent gossip, kind of what the kind of topic space looks like, and where are you taking this?
Yeah, given the short time I have, this just very vague vision is that the perfect hierarchy of hierarchies would be the hierarchies of hierarchies all the way down to you there on the table. So think of you as, I don't know, if you don't know what a binary tree is, look it up on Wikipedia. So every one of us should be a leaf in this binary tree. And by going up with our intents along this binary tree, we will find the closest match. And that's how it should go, the intent gossip in theory. And well, I guess that's 7 seconds. Yeah, I'm a theoretician. I love to discuss how this might be in conflict with what's actually going on in the real world. And I want to say big thanks to Sam for hosting the thing here. And I would leave the final words to whoever wants to grab now the mic.
Yeah, this was great. Thank you all.
Oh, thanks.
We're staying here.
We do have time for some questions. Just checking, does anyone have questions for the panelists about the topic? Just raise your hand if you want to ask anything. Okay, I do have a question though.
Sure.
Privacy-preserving peer-to-peer protocols, is it a problem for cryptography or distributed systems?
There's a section of both.
Together.
I think it's both.
Oh my God.
We have consensus.
Yeah, I don't think we should let non-cryptographers develop cryptographic solutions. They will mess it up.
Are you all going to do some kind of onion network thing for Anoma? I don't know.
So far, I haven't seen like the designs for like privacy at the peer-to-peer layer per se, outside of like encrypting intents or something like that.
You should speak into the mic, then I can hear you.
Yeah, but I think that's a question for Christopher, not for me.
Yeah, Chris, there's your question.
Yeah, I mean, it is possible to do. A Tor is,
Oh, Tor is nice, yeah. It's like a donut, but without the inner thing, right?
I do have a
Chris
question.
has the mic.
If we still have time. Do you think there are fundamental trade-offs? Not in terms of designing different peer-to-peer layers for different applications, clearly that makes sense and has garnered some consensus, but in terms of things that an application cannot both have at once in peer-to-peer networks, and what are they?
Throughput and latency, that's usually the case, right? Because the more layers you put until the execution layer, the slower it will go. But this may enable, so for example, Narwhal protocol, it's a good example, right? Because it does increase the throughput, but at the cost of latency. So, yeah.
I mean, privacy is definitely one of those, because typically in an onion network, you want to disseminate transactions to multiple parties. So you take a latency hit in order to get additional privacy.
Anyone else has questions? Oh, sorry. Go on.
I also imagine there's, when you get into intent matching worlds, now you want to integrate that into your topic creation and dissemination logic. So you have to think about like, how long do I hold on to transactions? How long do I, like, how widely do I disseminate them? And if you're kind of calling that part of your peer-to-peer layer, there's like lots of trade-off, like that just kind of infinitely expands the trade-off space.
I think it's also the more complexity you add to the system, the more points for centralization you have, right? So we see that at Ethereum with the builders, right? Or with intents, you will have solvers. And that's a clear point of centralization, right? If I run a solver network, I control the entire blockchain. Doesn't matter how decentralized it is afterwards.
Time for one last question. Okay, I'll take it. So heterogeneous paxos. Oh, did you have a question too?
No, go for it.
Okay. So is there any research indicating that there is another evolution of consensus algorithms after heterogeneous paxos? Or is heterogeneous paxos the latest?
I think we have to mention that there are several dimensions in which you can say, in which research is done. So what is new about heterogeneous paxos and is actually goes hand in hand, at least conceptually, with these ideas of having several domains which are interconnected. In short, heterogeneous paxos is a way to make validators of different, let's say, pre-existing chains talk to each other directly. That's my short version always. And this is only possible, of course, if there's a minimal mutual respect and or trust. This is the new thing that heterogeneous paxos is bringing to the table. The idea of having trust conditions and is a wide open research topic that I would say like ping Isaac Chef on Twitter. What I would want to add as one sentence in this context here is that another dimension is the trust assumptions that you kind of have inside of your consensus mechanism. And there's essentially like one big road of research would be to bring the consensus algorithms that we have in heterogeneous very closer to what's out there in peer-to-peer land. The buzzword for who wants to look it up is partial synchrony. It's a well-known assumption from distributed systems. And it kind of clashes really with everything out there in peer-to-peer that I've seen so far. So that's actually the real research challenge that's still out there.
Great. Thanks,
All right.
everybody.
Thank you. Let's bring our hands together. If you're curious to learn more about the P2P layer research and everything around consensus and Typhon, you can find information about it in the specs, also on Art or on the Anoma blog.